more research, or any research really, almost none has been done on secondary implementations. So there's a lot of research, someplace like Colorado might develop a curriculum and research how effective it is here. And then oftentimes where it's developed, they might get a couple of pilot sites which work closely with the main institution in terms of trying it at other institutions. But then that's it, it's done, and we kind of disseminate it out. And the reality is that most people who adopt anything are going to do it without the support of grant money. They're going to do it without any direct connection to the developer of that. And they're going to do it in environments that are very, very different from the ones that it was developed in. So for example, the last 2 years, the school that I was at was just about as different from here as you could get. And what I found is that most of the materials coming out of the PER community didn't work. For all kinds of reasons, they just didn't work. And it was very difficult trying to figure out what would work because I couldn't just take what was there and follow it, right? And so this is where the secondary implementations come in, is that when someone does take this material and they try to apply it to their local environment without all of the grant support and the direct support of the developers, what happens? What are the common difficulties that they encounter? And how do they typically deal with those difficulties? And how might the developer support that? So for example, we're doing a lot of interviews now with peer instruction users. And it very often comes up that people really don't know how to manage the groups very well, how to really get the students to buy into it, and how to manage the group interactions. And there's not a lot of guidance for them on how to do that. But this is often what leads them to abandon it, right? They try it, it's not working very well, they don't know what to do. They just blame the method or whatever.
The curriculum's stupid.
Yes, the curriculum's stupid. And they give up. And so this is one place where, if this is going to be disseminated, we really need to find out more about what the common difficulties are going to be in these secondary implementations and do more to support faculty as they implement those. And then this last one actually, it's really obvious in hindsight, but it was kind of neat to see it. Is that, one of the things we did in our interviews is we asked everyone, how do you know your instruction's working? And a good portion of them just kind of stopped and said, wow, yeah, that's a good question. How do I know? And then, most people didn't think exams were a very good measure. I don't think anyone thought the student evaluations were a good measure. We haven't tabulated the data yet, so I should say I'm doing this based on my memory at this point. This is one of the analyses that we're going to do. But a lot of times people would just say, well, by the kinds of questions that they're asking in class, or by the interactions I have with students in their office hours. In other words, they really don't have a good way of knowing whether their instruction's working.
Did I understand you correctly? Is that the faculty involved in this, in trying to adopt these, they do not feel that exams are a good measure?
Most of them don't.
They do not.
Most of them don't. Yeah, some people mentioned it, and like I said, we haven't done the analysis, so I can't tell you what the exact breakdown is. But most people, were kind of like, yeah, and some of them even said, eventually they're like, actually, I guess I don't really have a good way of knowing when my students are learning.
Your much more abundant experience in physics is different from my mostly anecdotal experience in chemistry, so I wouldn't draw any conclusions about it. But I have found that not only traditionally trained faculty, but even people in the chemistry education research community tend to focus on exam. I was at a conference in chemical education this summer and heard 3 different talks about people who were evaluating methods of peer instruction and noted that the exam scores, like the scores on the ACS standardized exam, were not much different, and concluded that they concluded that peer instruction is still good for attitudes, but it doesn't really.
It may be because you have a standardized exam in chemistry and we don't in physics. So they're really talking about their exams that they would make up, because we don't have the same thing that you have in chemistry.
Yeah, but it is a standardized exam, but I don't think it's aligned towards the
learning goals.
Towards the learning that you're trying to induce in the instruction. But anyway, that's just my anecdote.
Kathy?
to talk about this later. If you are, then hold on. But if you're not, can you reflect on kind of what your interviews pointed towards as potential approaches to helping these faculty overcome, some of the barriers, or what would you recommend for approaches for teacher development?
Yeah, so we're still kind of in the middle of all of that. I guess a lot of the stuff that I identified here, like having a community, a supportive community. And in fact, I'm going to mention it in a little bit. We did some analysis a couple years ago on the modeling project, the physics modeling project, which is really, like, in terms of like high school curriculum, has been enormously successful. Like the people who are into that, it's almost like a cult. If you talk to them, it's like I'm a modeler, are you a modeler? And the actual curriculum itself is not that different from a lot of other curriculum. In fact, it's hard to say what it is. It's actually kind of interesting. I don't even know if it is a curriculum. It's just sort of this nebulous modeling thing. But the ideas that they use are not
take that from her, May. May's a modeler.
So you know.
We all know.
But when we went in and we did some analysis of that, what we found that was different about the modeling program than any of the other curriculum, which is very similar actually for high schools, was that it's a community building. Right, that there's this community of modelers, and the developers of the modeling did not try to take charge of it. They tried to facilitate the building of the community and respected the individual teachers and encouraged them to take it on. And so that's why it is. And there's a lot of support that they have from each other. I don't know if you want to add anything to it.
I agree with everything you said. It's really nice. Even though I'm not teaching anymore, I still consider myself, I guess, part of that community. And you don't, it's I don't know, it's the listserv or the ways that you can stay connected with the community even if you're not currently teaching and using modeling.
I think you just said it. You said, I feel like I'm part of that community. Like there is a community there that they've developed.
Not to get distracted into the modeling zone, but so we made a pretty careful search of the literature and didn't find reference to that study that you just described, that you found that
and actually I'm going to talk about that in just a little bit, as to where that is and what it's. This is one of my places for people to get involved with.
Okay.
So here's two things. I presume that one of the reasons for the new faculty workshop in physics is to address some of these things that a personal contact is more likely to get you to try something new. I think they have in mind to build some kind of a community among new faculty, although that's a little problematical because they come from different places. What I can say, though, remarkably, is here is where astronomy has had an incredible success. And it has come directly from support from 3 heroic people with a Phase 3 NSF grant. And in the last 6 years, they have personally done workshops for 1/4 of all the faculty in the country that teach astronomy, and that group is networked over the internet with their own group, and it is enormously supportive. So
yeah, I have to say it's interesting that you said that, because we're like right now we're kind of reading through the interviews, but we don't have, I just have my general sense in my head because we haven't had a chance to tabulate everything. But one of the things that I mentioned to Charles and Chandra is I'm like, there's so many people that we keep coming across who say, well, I first started doing all this stuff in astronomy and it was working so well that I decided to try it in physics. Like astronomy seems to be an avenue by which people are actually getting into doing more innovative stuff in physics.
And it's actually one single group that does 10 workshops a year.
Who?
Ed Prather, Gina Brissenden, used to be, what's his name? Tim Slater. And that's 6 years. See, we have the advantage over physics that we only have about 1/4 as many faculty. So it only takes us 1/4 as many logistics to reach the same percentage with support. But I think this would be an excellent case study to look at.
And that's insane.
But we have our new faculty workshops that also serve.
Yeah, but
we
this
don't
is
have 10 per
ongoing.
year.
This is ongoing. People come back after a year to do another workshop, and they talk several times a month over the internet. So it really is a modern community. It's amazing. Now, they are right that the three people who do this work about 70 hours a week to make it happen, but that's how you do political organizing.
Yeah.
I'm curious because both of these things that just came up in terms of the astronomy community and the modeling community start with this sort of common framework, it sounds like they're starting from some shared experience, and
Right.
that's where
Right.
would you both agree with that? So it's not just community, it's a community that has a common vocabulary and a shared experience from which they're building.
Very well put. I think that's very important.
Because people always talk about building community, but if there's something to build the community around,
right.
So
They're
I
not just randomly
a thought.
picked.
Yeah, I mean, can there be any other kind? Which is another complimentary question.
yeah. Well, people try to build ones that we don't have that common.
We're actively trying to do that, Stephanie.
So these are sort of the things that, in terms of this, we don't have the answer to what this model looks like, but we've just identified, these are things we've identified need to be considerations in it or a part of it in order for it to be successful.
I have one more question. You said that modeling in comparison with the other curriculum that you compared it to had a community. So what was the other curriculum?
Well, we didn't do direct comparisons with other curriculum. It's just that what we did, we set out and we said, why in the world is modeling so successful? Like, why is it known so much?
Yeah.
And why are modelers so enthusiastic? And so we started looking at that, and what we found is that what we believed was that it was this community that they had.
But you
that-
didn't, in fact, compare it to.
We did not know. Do that. So just a couple of other things that came up that, I thought are sort of interesting. Faculty aren't these curmudgeonous people that just want to do their research and don't care about students. I don't think we've found, in all the interviews that we've done, I don't think we found a single person who falls into this category. Now, they probably are out there, and maybe they didn't respond to our request for an interview. And, everybody knows that. When I say this, people always tell me about that one person down the hall and blah, 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 blah. Okay, so that's one person, right, down the hall, The reality is that most faculty do actually believe that students need to be interactive and engaged and social in order to learn, and they do really care about their teaching, and they really want their students to learn. That is true of most faculty out there. They over-report, so we found them to be pretty unreliable indicators of what they're actually doing in their classroom. They will tell you that almost every faculty member will say that they have an interactive classroom. Okay? And then sometimes, we've got even a few funny quotes where people will say, oh yeah, my classroom's interactive because every now and then I turn around and look at them. But they have this sense, and I think it's this disjunct between what their beliefs are, that they really do believe that students need to be engaged to learn, but they recognize it's not what they're doing, and somehow they have to reconcile that in their head, and they're not doing it for reasons that aren't just that they don't want to, right? It's hard to do, the chairs are bolted down, all these other things. So they tend to over-report what they know about, they tend to over-report what they use, so what we found is that you can't just ask faculty directly. You have to ask them the same question multiple times in multiple ways to really get a sense about what the answer might be. We found the new faculty workshop, as far as anything else, is the most effective thing out there. I put effective in quotes because I don't know how effective it is at long-term sustained change, but it's more effective at getting faculty to know about and get enthusiastic about using some of these things than any other thing that we've identified out there. So this is certainly an avenue to follow up, and which is a big part of why we picked this as our next project, is to follow faculty who have gone through that.
So this is just in physics? So like
Physics,
okay.
yeah, this is just physics.
You didn't like with the Ed and Gina?
No.